So I will start in BGP. Actually, we are going to start today what conditional advertisement, conditional route advertisement. First of all, I'll teach you this conditional route advertisement, and then I'll go for conditional route injection. Before going for doing configuration of conditional route advertisement, it's mandatory for us to understand that where can we implement this conditional route advertisement, because it is not possible to, it is not always required to configure this conditional route advertisement. But the thing is, like, you must be aware of where to implement this conditional route advertisement and in which conditions we can implement it, in which conditions it will be required for us to configure conditional route advertisement, right guys? So let's assume now that you are a customer and you have taken one internet connection from ISP1. You have also taken one connection from ISP2, which is satellite connection. Let's assume it. This is primary connection because this is cheaper actually, right? But this internet connection from ISP2, this is like kind of a satellite connection, and it is too much costly. It is much costlier. So it must be your primary and it must be your secondary. I got my point. So this is your primary link and this is your, let's say, secondary link. Now from the lane users of customer, internet must be reachable through primary link. The only thing that in case primary goes down, then customer should start to use the secondary link. And one more thing that I would like to tell you, even reverse traffic should come via primary link only. I got my point. Not only outgoing traffic, even incoming traffic should also come in to the customer's network via primary link only. Now in normal cases, what will you do? You will advertise your lane prefix from customer into BGP. BGP will advertise that prefix towards ISP1 as well as ISP2. It means reverse traffic, incoming traffic can come via primary as well as via secondary link. It will be depending on the path selection of ISPs, path selection processor, right? But we have to manipulate it, right? But if we don't want to take risk, over here, then we can configure conditional route advertisement as well. Over here we can configure conditional route advertisement, by configuring conditional route advertisement we can achieve this task with the 100% security. Like, what can we do? That if primary link is up, just try to understand, if primary link is up, then customer should advertise its own lane information via primary link only. It should not advertise its lane information, its prefix information in the direction of ISP2. So in case if ISP2 do not get any prefix information from customer, will it be possible for ISP2 ever to transmit data in the direction of customer? No. If ISP2 do not have return path towards customer, how will it be possible for ISP2 to transmit data in the direction of customer? I got your point or not? But in case if this primary link goes down, then customer should start to advertise prefix in the direction of ISP2. So that now ISP2 will be having returning path, reverse path. It's not it. However, customer will keep on to receive prefixes coming from ISP1 as well as, but by modifying their local preference or weight, we can define its best path via ISP1. So in case if ISP1 will go down, this primary link goes down, in that case customer will define its best path via ISP2 automatically without any problem. But what about reverse traffic? For that purpose you have to configure here conditional route advertisement. So you can put this condition on customer that in case the primary link is up, till that customer router must not advertise any prefix information in the direction of ISP2. But in case the primary link goes down, then it should start to advertise prefix information in the direction of ISP2, so that ISP2 will be having reverse path. So to achieve this type of condition, or to achieve this type of task, we can configure conditional route advertisement. Understood or not? Now, how will you define this condition? Like, there is no track object that you can call in BGP, nothing like track, but here you can use exist map or non-exist map. You can put a condition in BGP during route advertisement of exist map or non-exist map. See, if primary link is up, customer will be receiving prefixes coming from ISP1, is not it? Just try to understand. If this primary link is up, then customer will keep on to receive a prefix from ISP1. Are you getting my point? And make sure that you are not receiving that prefix from ISP2. A single prefix. You can ask to your ISP that, okay, do one thing, just advertise one special prefix to me only. Right? You can ask to your ISP1. So if that prefix is coming onto customer router, it means primary link is what? Up. It means primary link is up. So what can we do here on customer? That if prefix is coming from ISP1 via primary link, then we can put a condition that if that prefix is up, till that customer will not advertise any prefix information towards ISP2. If that prefix is not available, and when will it not be available over here? When this primary link will go down. If this primary link goes down, then definitely customer will stop to receive that prefix coming from ISP1. In that case, this customer router will automatically start to advertise its lane prefix information in the direction of ISP2. So here you have to take condition of non-exist map or exist map. If this is exist, then you will not advertise. If it is not exist here, then you will start to advertise. It means you will take condition of non-existence. You will take condition of non-existence. However, you can also take condition of existence as well. Like for an example, sometimes what happens, this is one of the condition in which you can configure conditional route advertisement. Apart from it, you can also do this type of configuration in such kind of scenarios as well. This is R1, R2, this is R3. R2 is advertising all prefixes towards R3, whether it is coming from R1 or it is coming, it is lane of R2. Now what I want, that R2 should not advertise any information if the lane of R1 is not present onto R2. The only thing, because this is really important, right? And if this lane information of R1 is not present on R2, then R2 should not advertise anything towards R3. So here we can take condition of exist map. Like if it is existing, if this prefix is existing onto R2, till that it should advertise this prefix towards R2. If this is not existing over here, then it should stop to advertise all this information in the direction of its neighbor. So actually you can put condition of anything like existence. You can take a condition of existence of prefixes or non-existence of prefixes as well. And I'll perform this practical in both ways, right? In case of existence as well as non-existence. So see, first of all, non-existence. Like what I want, that see this time BT, sorry, this is BT. It is advertising prefixes in the direction of R5 as well as R6. Do one thing, router BGP 35500 neighbor 101.1.1, just shut it down. So that now it will start to advertise, it will keep on to advertise prefixes in the direction of R5 and R6 only. Now what I want, that if 100.0 is not there, if 100.0 is not there, then only BT should advertise all these prefixes in the direction of R5 and R6. Are you getting my point or not? Or in the direction of R6 only. Just try to get my point. In case if 100.0 is not there, or what do you want? Exist map or non-exist map? First, existence. So what can we say? If 100.0 is there, then only this BT should advertise these prefixes in the direction of R5 and R6, right? Let me do that now. Go to BT, show IP BGP. So this 100.0, so I want to put this condition that if this 100.0 is available, then only it should advertise all these prefixes in the direction of R5 as well as R6. So for doing that, I have to create one prefix list first of all. In which I can put, I can take its name as exist permit 192.168.100.0/24. Fine. And then okay, let's do one thing. Let's apply it for all prefixes, right? That okay, all prefixes should advertise only in that condition when this 100.0 is available, right? So I have created only one prefix list over here. However, you can also create one another prefix list for those prefixes to whom you want to advertise towards your prefixes. But here, let's say that we will apply it for all prefixes. Now, create one route map for exist. Let's say its name is exist map. You understand? Exist map or simple exist map. Permit 10. Match IP address prefix list name was exist. Fine. Just come outside. Now create another route map for those prefixes to whom you want to advertise towards your neighbors. So route map, let's say its name I have taken is advertise. Permit 10. You don't need to match anything because by default match all is there. So it will be applicable for all prefixes. Have you understood or not? So here I am using two different route maps. One is for those prefixes to whom I want to advertise towards my neighbors. Another route map for your condition. Like I wanted to advertise all these prefixes when that prefix is existing. Now go to BGP router. BGP is 35500. Go to your neighbor, like neighbor is 201.100.100.6. Advertise map. And then your route map name that you created for advertise, right? So its name is what? Advertise itself. For all prefixes are there, right? And then here you have two options, either exist map or non-exist map. So if you want to apply this condition in case of existence of prefix, I mean like if you want to advertise all these prefixes in case if that prefix is existing, then you will take here exist map. If you want to advertise all these prefixes in the non-existence of the prefix, then here you will call non-exist map. So it will advertise these prefixes in that case only when 100.0 is not there. Leo. So accordingly you have to opt your condition, or you can say this keyword. Like I want it to advertise all these prefixes in that case only, in that condition only when 100.0 is existing over here, right? So I'll say exist map and then your route map name, and it was exist map. That's it. Then after you do not have anything. In same manner you will apply it for your neighbor R5. So it was 200 105 100.5. Do clear IP BGP start out. Understood? So this time, see, this time it will advertise all these prefixes in the direction of R5 and R6 in case of if 100.0 is existing over here. If 100.0 does not exist here in the BGP table of BT, then definitely it will not advertise any prefix information. Fine guys, let's prove it now. To prove it, move back over again on BT, sorry, New York router, loop back one and just shut it down. Do show IP BGP, check it out. It's gone. Now if you move on BT On BT you must not get that prefix, that 100.0. And now this BT must not advertise anything, any prefix information in the direction of R5 as well as R6. Fine guys, now do one thing, move back again on your router, say now shut down, so that now you will see that on BT is there once again. Now you go to R5, or just wait for a moment, on R6 as well. Fine guys, see on R5 as well as you can move on R6. Fine, now once again move back on New York, shut it down. On R5 and R6 you must not get any prefix now. It will take some time to update, right? Just wait for a moment. Again I'll stop the gone. In same manner you can move on R6, gone. If it comes up once again, and I'll put its reverse action. I'll say if 100.0 is there, it should not advertise. If 100.0 is not there, then it should advertise all prefixes towards R5 and R6. I get my point. If 100.0 is there, then it should not advertise anything towards R5 and R6. But if 100.0 is not there, then it should advertise reverse action. So in that case you just need to change only one keyword over there. In place of exist map you have to take non-exist map. Move on BT, do show history, and just remove this command from here and remove it as well. And now non-exist map, and name was, you applied it for 6, also apply it for R5. Do show history, check it out. Fine guys, so this time I have taken non-exist map. However, route map name is still same, exist map. It was good, it will be good to rename this route map as well, because this time you are taking condition of non-existence, right? So it will be good to create your route map with the name of non-exist only, is not it? But this time I'm using the same route map, don't worry about that, right? So it doesn't matter because it's a name only. So this time do show IP BGP, check it out. This 100.0 is there. So it should not advertise anything in the direction of R5 and R6 till it is existing there. Let's move on R5. It's not there, see. On R6 also you must not get anything. But in case if 100.0 is not there, so let's say this is now shut down. So what will happen that now BT will not keep, will not have this prefix in its, BGP will not be having this prefix available inside its own BGP table. And if it is not having this prefix in its BGP table, then definitely it must start to advertise all these prefixes in the direction of R5 and R6, both of them. So let's move on R5 now and let's check its BGP table. So you must get all those 3 prefixes over here. And in same manner, if you move on R6, then also you must get all those prefixes information in its BGP table. So I think now you people have understood all these things. Tell me, hello, have you understood the uses of conditional route advertisement now? So you can take any type of condition, whether condition of existence or non-existence. So it will be depending on your requirement. So according to your requirement, you can design your configuration. You can create your configuration. So I think you people have understood my I mean this feature of BGP successfully now. If there is if is there any problem, I mean if there is still any problem, then you can tell me, and definitely I'll let you know. Due to, I mean, regarding this conditional route advertisement. Done? Are you okay with that? For sure. Let's go for conditional route injection now. Conditional route injection. So let's move on BT. First of all, let me remove it from here. 35500 to show history. Just remove it. Even I can remove all route map, no route map, and its name is exist map, and no route map advertise this word show route map, nothing. Clear IP BGP star out, and then after you can also do one more thing, you can say no shutdown, so that it will again start to advertise this 100.0 prefix into the BGP table, right? So this is all about conditional route advertisement. Now we are going for conditional route injection. Do you remember that we configured unsuppressed map? Do you remember that what was the uses of unsuppressed map? Tell me, what was the uses of unsuppressed map in BGP? What was the uses of unsuppressed map in BGP? What? Leak map, exactly. Yeah. The uses of unsuppressed map was same as leak map. Fine. But there was a condition that unsuppressed map could be configured only on that device, only on that router where you configured aggregation. Right? Now, let's assume that you are an ISP router. You are having a prefix 10.1.0.0/16. You want to advertise it now towards customer. Whereas this I just require to advertise only 10.1.50.0/24. This prefix information towards customer. However, because I'm having this aggregate address, I mean ISP is having this aggregate address available in its own BGP table, so it will advertise this whole, I mean this existing prefix information towards customer, and which is completely unacceptable. If customer is asking only for this prefix information, so we should advertise only this prefix information. Is not it? But here you cannot configure unsuppressed map, because unsuppressed map can be configured only on that router, only on that device where you configured aggregation. That was the limitation of unsuppressed map. So conditional route injection is a solution of it. Conditional route injection is a solution of it. With conditional route injection works same as unsuppressed map, but the point is conditional route injection can be configured anywhere in the network. Like if you are having aggregate address, you wanna split your address, your prefix into multiple prefixes. Now you can do it with the help of conditional route injection. Have you understood the uses of conditional route injection or not? See, it's same as unsuppressed map. The problem was with unsuppressed map, like it can be configured, I mean it could be configured only on that router where you configured aggregation, but conditional route injection can be configured anywhere in the network. So what will I do now? I will move back again on your router, and over here itself I'll configure aggregate address now. Router BGP 8127, and then I'll say aggregate address 192.168.100.0 and 245.255.252.0, I think so, right? And then you can say summary only. Is not it? Fine. It will advertise only and only summary address now in the direction of BT. Check it out. And it will also advertise only and only, I mean this prefix information towards R5 as well as, see, R5 is receiving only this. Even R6 is also receiving only a single prefix. Then R5 and R6, both of them will also advertise this prefix information towards R1. Only this aggregate address, right? Now what I want that R6 should advertise. R6 should advertise only this 1 or 2 information. I mean R6 should advertise this 1 or 2 separately, individually. R6 towards R1. As well as, of course, R6 will start to advertise it in the R6 will start to advertise it in the direction of R1. Let me show you now. Are you getting my point or not? So this time R6 is receiving only and only this prefix. See, here you have to inject individual prefix in BGP. So it is possible with using conditional route injection. Fine, guys. So first of all, create one prefix list or access list and match that prefix to whom you want to inject here. So I'm creating now prefix list, IP prefix list. Name is what? Inject. I want to inject this prefix only, which is sorry. Fine, guys. I have created one prefix name with the name of inject. Fine. Then you have to create one route map. You have to create one route map. For injecting your prefix. Name with set IP address. This time do not match it. You are not matching it. You are injecting it. That is why you have to say set. Because with using a match command, you will simply match your prefixes, right? You are giving match condition. But here you are not giving match condition. You have to inject this prefix. That's why you have to use set keyword, set IP address, prefix list, name is now. You have to put condition as well. It should inject this prefix in that case only when it is receiving that aggregate address, right? Hello? Are you getting one point or not? It should inject, this router should inject this prefix in that case only when it is receiving that prefix. So now you have to create another prefix list to match that prefix which is mandatory to exist before injecting this prefix over here. So create one prefix list over here. See, try to understand. Definitely this R6 should inject this prefix in that case only, in that condition only, when it is receiving that aggregate address. So you have to create one prefix list to match that aggregate address, and then of course you will also require to create one route map as well. Understood or not? So now create one prefix list first of all, like condition permit when it is receiving slash one another prefix list will also required. You have to also tell that when it is receiving this aggregate address from its neighbor BT, you have to tell, I mean you have to also configure this condition that when this router is receiving this aggregate address from this neighbor, then only it should inject that, I mean that 192.102.0/24 prefix into its local BGP table. So you do one thing, create one another prefix list, source permit 201.100.100.1/32. It's not it. This is your source. So you have created two prefix list here, right? And now create one route map for condition permit match IP address prefix list, name is what? Condition. match source match IP route source, and from where? Now your prefix list name was, I created another prefix list with the name of source. Do show history now, check it out. So under route map condition, I put two match conditions over here, that prefix, that aggregate address must available, and also that aggregate address must be received from this particular neighbor. Then I have also created one other route map for injecting your prefix, right? Hello. There are two different things. One route map used to tell your device to inject prefix. Another route map used to put some conditions, that if these conditions are fulfilled, then only it should inject this prefix. Kind of conditional advertisement. Have you understood it or not? So this time R6 was receiving this prefix from BT only. That's why I have matched that condition as well, that if it is receiving this aggregate address from this particular neighbor, then only it should be able to inject that prefix, right? So let me apply it inside BGP now. Router BGP name is, AS number is what? 65500. Say BGP inject map and it will be configured globally, not for a particular neighbor. You cannot apply this command for a particular neighbor, so you will apply this command globally. So BGP inject map, it will ask for route map, it was inject itself. Inject, and then here only exist map, right? Of course, here we are having only one condition, which is exist map. Exist map when that route map, hey, if not source, actually you took condition. If you wanna copy your attributes, of course you have to copy it. If you do not copy your attributes from your aggregate address back into this individual prefix, then it can go back. Hello. If you are injecting this prefix over here, it can go back towards BT if you do not copy attributes from that aggregate address into your individual prefix, because it will look like it is advertised from R6 itself. But if you say copy attributes, then it will copy all attributes which are coming with that aggregate address into your individual prefix as well, so that if this R6 advertises that prefix back in the direction of BT, then BT will simply drop it, discard it, because it will find it's on AS into received prefix. Hello. So it is good, it will be good for you guys to use this copy attributes over here. Then after, you do not have anything else. So this is called conditional route injection. Do show IP BGP. Just wait for a moment. Say do clear IP BGP star in. Do show IP BGP. Oh my god, have we done some mistakes over here? 201 100.1 /32, that's fine. Source prefix list source, this is condition, fine. CONDITION, fine. Inject set IP address prefix list, inject. Prefix list name was inject. Route map was also inject. Do show IP BGP. Even it is looking like it is coming from that particular neighbor. However, that neighbor BT is not giving any information to it. You can check it out on that neighbor itself, like BT. Even you can also configure this command neighbor, show IP BGP neighbor 201.100.100.6 advertise. But according to the BGP table of R6, are you okay guys or not? So this is kind of unsuppressed map, but the thing is you can configure it anywhere in your BGP, anywhere. Even it is not like that you can break your aggregate address only. You can break any prefix, whether it was aggregated before or not, doesn't matter. Let's say you are receiving 192.168.100.0/24, but you wanna break it now 100.0/28. You can do it. However, it will keep that prefix as well, but along with that, it will also inject that prefix that you have injected in your BGP table. So now you do one thing, move back again on R1. Check it out. 102 is coming from R6 only. So I hope that you people have understood the features of BGP now. So of course this is really very good feature of BGP, because in some cases of course you can require to have this type of requirement. I mean, you can have this type of requirement in BGP anytime. So if you are having this type of requirement, then you can achieve it very easily with using conditional route injection. Understood or not? Tell me. Good. After it, move back again on R6. So now
इसके अंदर हम लोग 14 तक कर सकते हैं ना, वो अलग अलग चीजें बना। इसके अंदर फिर हम लोग जो एग्रीगेट एड्रेस आ रहा था 4 को कंबाइन करके उसको 4 के अंदर वापस डिवाइड कर सकते हैं। अगर हम लोग अलग अलग इंजेक्ट लिस्ट बना के अलग अलग राउट मैप बना के इंजेक्ट के लिए
समझ नहीं आया मेरे को क्या कहना चाह रहा है।
अभी हमने
इसमें पेट नहीं भरा इतना भी करके। हाँ,
अभी हमने इसको एक ही लीक किया है, इसके अंदर 4 को भी लीक कर सकते हैं वापस से।
सर इंजेक्ट मैप एक ही कमांड चलेगी एक डिवाइस पे। अब उसमें जितना भी इंजेक्ट कराना है करा लो आप। मल्टीपल सेट कमांड्स दे सकते हो एक ही राउट मैप के अंदर। मल्टीपल सेट कमांड्स दे सकते हो आप। Fine guys, so in this way you can do all this type of configuration. So this is done now, conditional route advertisement as well as conditional route injection. So again everything is in its default state once again. And now next topic is going to be related to migration now in BGP. Related to migration. Let's assume that New York router, and behind this New York router you are having multiple routers. Are you getting my point? New York router as well as behind New York router, all routers. I mean at New York site you are using AS8127. Are you getting my point or not? We are also assuming that you are also having some other prefixes behind New York router. I mean like router 10, 15, something like that, and all of them are having IBGP neighborship with each other, right? And then finally New York router is advertising all these prefixes in the direction of BT. And also what will I do? I will move on R1. I'll create one loopback. I can take, I think loopback 1 is not there. Let me see. Yes, loopback 1 100.1.1, loopback 2, loopback 3, router BGP. It's using 65500, network 100.1.0. mask swipe BGP. You will also see other prefixes sooner, because the minimum time interval in between two consecutive advertisement is what? 30 seconds. See, understood? Fine. Now BT, on BT actually your remote AS is configured as 8127, but you are doing some migration now, and now you wanna configure AS 8000 in place of 8127 within this site. Have you understood it or not? Now you will ask to your service provider BT that, okay, do one thing, change my remote AS. BT will say that, okay, I'll do that according to my SLA, service level agreement. Are you getting my point or not? So BT can ask you to take like 24 hours, for sometimes 48 hours, or sometimes like 72 hours. It will be depending on the agreement in between you and your service provider. Fine, guys. So now you cannot wait for BT's configuration, right? You decided that, okay, I'm going to update my own AS. So new router, they said no router BGP 8127, and now they configure router BGP 8000. Router BGP 8000, sorry, router BGP 8000, and then they said neighbor 101.1, sorry, I think it was using 80, right? 80.1.1. remote AS is what? Now it will start to give you an error message of wrong peer AS, something like that. It will start to give you notification message, right? Peer in wrong AS. Of course it will show you, because over there we configured remote AS as 8127, and right now I'm using here 8000. So of course ASs will mismatched and neighborship will never come up. How can you solve this problem now? To solve this problem, what can we do? We can configure multiple AS on a single router. Like right now, what is running here? AS 8000. Along with this, because I know very well that for BT I'm still using 8127, so I can also configure 8127 on at my own end for this particular neighbor only. For doing that, you just need to say this command as well, 80.1.1 local AS is what? 8127. What does it mean? That for this particular neighbor I will start to use AS 8127, not 8000. So in this condition only we can say that in BGP it is also possible to configure more than one AS onto a single router. You see, now it will start to use this 8127 for this particular neighbor. However, we are running only 8000. Are you getting my point or not? So this is the uses of local AS command in BGP. Now neighborship must come up. It have stopped to give you notification messages, so definitely neighborship will come up. And now you see, show IP BGP, let me do one thing, router BGP 8000, and then redistribute connected, so that it will also start to advertise its own prefixes towards that particular neighbor, right? Show IP BGP, check it out. So it is receiving all prefixes coming from there, and also it have started to advertise its own prefixes towards. Are you getting my point or not? Try to understand now. But the problem is, see, in all incoming prefixes, what is happening? What is this? 8127 has been prepended in all incoming prefixes without any reason. However, this New-York router is receiving these prefixes coming from directly BT. But see, 8127 has been prepended because we are also running this 8127 now in between this New-York router and BT. Is not it? We configured it with using local AS keyword. And due to this prependation of this AS of this 8127, what will happen? Let's say that New York router is having some IBGP neighbors in 8127 itself. Let's say that on those routers you have not applied AS 8000 yet. You are still running 8127. Are you getting my point or not?
Yes.
Let's say your downstream routers are still using AS 8127. Now, will it be possible for those routers to receive all these prefixes now? Hello. Let's say, as I earlier said, that in your site you are having multiple routers, they are running IBGP, right? So onto those downstream routers still you are using AS8127. So you can also use local AS keyword for them as well, right? Hello, to your downstream routers as well. So whenever this New York router, this edge router will advertise these prefixes 100.1.0/24, 100.1.2.0/24, 3.0/24 towards those routers, will it be possible for them to receive these prefixes? No, because they will think that they have already crossed their AS 8127, is not it? So how will you solve this problem? To solve this problem on New York router, what can we say? Router BGP 8000, and for this neighbor, as I said, local AS, I can also say no prepend. With using this keyword, it will start to stop prepend this AS 8127 in all incoming updates. But it will impact only and only incoming updates, right? Are you getting my point or not? So if any update is coming from BT towards this AS now, it will not prepend 8127. Let me show you. Show IP BGP. See, 8127 is not there now. It means now, in case if New York router, this edge router is advertising these prefixes towards downstream routers, which are still using AS 8127, will also start to accept, will also start to receive all these prefixes. Piyush, are you okay with this or not? So this is the uses of no prepend. But remember, this no prepend keyword will work only for incoming prefixes. And see, now go back to BT, and on BT check that which prefixes have been advertised from New York to BT. See, all these prefixes are coming. And what is happening? See, it is prepending 8000 as well as 8127. However, for BT we are running only and only 8127. If BT has configured this command that it must receive these prefixes from AS 8127 only, not from any other AS, then BT will start to discard all these incoming prefixes coming from New York router, is not it? So to solve this problem, now you do one thing, move back again on BT, move back again on New York router, and as you configure your no prepend command, router BGP 8000, along with that you can also say replace AS. This replace AS keyword will enforce this BGP to prepend that AS information only in its outgoing updates, which is actually running for that particular neighbor, So right now it is prepending 8000 as well as 8127, but right now for BT we are running 8127 only. So after using this replace AS keyword, you will see that it will start to prepend only and only 8127 in all outgoing updates. So this replace AS will work for outgoing updates, whereas no prepend keyword will work for incoming updates. So move back again on BT and check its BGP table now. Only 81 8127. There is nothing like 8000. And now there is a little problem now. Let's say BT have changed now its remote AS from 8127 to 8000. Again its neighborship will go down. And again you have to remove that local AS keyword from there, right? So it can cause a problem. To solve this problem, what can we do? We can do one thing. After replace AS, we can also use this keyword dual AS. So it will happen that this new router will start to use both ASs for this particular neighbor 8127 as well as 8000. So if neighbor is coming with AS 8127, then also it will form neighborship. If if BT is coming here with AS 8000, then also it will form neighborship. And this replace AS and no prepend will also work along with that. So now you will see that neighborship will come up once again. Just wait for a moment, right? It will form neighborship. And then after I will move there on BT and I will change remote AS, and then I will show you that neighborship will come up automatically. It will give you this notification message, don't worry, because right now it is using both ASs. But finally neighborship will come up. You see? Show IP, BGP. Check it out. All prefixes are coming over here. And right now, because we are using 8127, so BT must receive all these prefixes with AS 8127 only. See, because we have used replace AS keyword. Now, on BT, I will change its remote AS. In place of 8127, I'll make it 8000 now. I'll show you that we will not require to do any modification at the end of New York router, and neighborship will come up automatically. So router BGP 35500 neighbor 80.1.10 remote AS is what? Do show run pipe section router BGP. Let me show you. Fine. In place of 8127, we have started to use now. See, neighborship have came up. Show IP BGP. Check it out. Now it will start. New York router will start to advertise all those prefixes after prepending only 8000. This is the uses of replace AS keyword. And now you move back again on New York router. Show IP BGP. Check it out. No prependation for incoming updates as well. So after dual AS, you do not have any other option. Don't worry about that. So router BGP 8000, and then after dual AS, you do not have anything else. So I hope you people have understood the uses of local AS, no prepend, replace AS, as well as dual AS. So these things will be used in BGP during migration only. If you are not doing migration, then definitely you will never require for doing this type of configuration in BGP. Fine. Okay, this is also done now. After performing these things in BGP, now let's discuss about fast follower. Fast fall over. You know, sometimes what happens, let's say that there is a IBGP peering in between R1 and R5. Are you getting my point? With using their loopback addresses, loopback interfaces. And their loopback interfaces are reachable to each other with using IGP, which is OSPF over here. In case from R5, the loopback of R1 becomes unreachable due to OSPF. This BGP will take 180 seconds to break its neighborship. BGP can break neighborship immediately in that case only. Let's say right now New York router has formed a neighborship with BT with using interface FA0x0 IP address itself. If I shut down FA0x0 manually and if its line protocol goes down, then only BGP can break its neighborship immediately. But if you have configured its neighborship with using loopback, it will not work. It will not break its neighborship immediately. Let me show you. If I move on New York router and if I go to its FA0x0 and shut it down, you will see that BGP neighborship will also go down immediately. It has gone down. It will come up once again. Don't worry about that. So in case if your neighbor is directly connected, then if your interface is going down, then BGP peering will go down immediately. If it comes up, it comes. If it comes back up, then definitely neighborship will also come up. You see that neighborship will come up very soon. It is in active state, still in active state. Let this BGP peering come up and then I'll show you that in case if don't worry about that. Fine. Check it out. Everything is fine. Now, in case if the loopback of R1 goes down, then definitely R5 should break its neighborship with R1. Right now, R5 is having neighborship. You see, so IP BGP summary. It is having neighborship with R1 and it is receiving 3 prefixes from there. Now, you do one thing: move back again on R1, go to loopback 0 and just shut it down. Now move on R5 to IP BGP summary. See, neighborship is still there. It will remain there. However, this neighbor IP address is not reachable. This is completely incorrect. See, is there 150.1.1.1/32? Tell me. This is the problem of BGP. To solve this problem, we are having a feature in BGP which is known as fast failover. You just fast failover, failover, not failover, failover. Yes. Fine. So you do one thing: move back again on R1, say no, shut down, so that it will become reachable from R5 now. Show IP route, you will see that once again it will start, it will become reachable from here, see, via OSPF. Fine guys, so this time I will enable this feature in BGP. To enable this feature, router BGP 65500, first of all you have to disable this feature, fast BGP fast external follower. Just remove it. This is for interfaces only, right? This is for, like if directly connected interface goes down, then only it will break its neighborship. Fine. Then you do one thing, go to neighbor 150.1.1 and say follower. This is called fast follower. So you are enabling this feature for this particular neighbor only now. After enabling this feature, what will happen, that whenever there will be any change in its RIB, whenever there will be any change in its routing table, it will verify its neighbor reachability. If its neighbor is not reachable, then it will break its neighborship immediately. Are you getting my point or not? So what is the rule behind this follower? That whenever there will be any change in its RIB, routing information base, then it will immediately try to verify reachability. It will verify reachability with, tell me,
the name.
have you got it or not? Now do one thing, say debug IP BGP and go back to R1 this time, say shut down, and you see now on R5 I shut down that link on R1. What is happening over here? See, there was a change in its routing table. Even you could say debug IP route as well, so that you could see that there was a change in its routing table. So see, established to ideal, route to peer lost. This is the uses of follower keyword. So it will be good to enable this feature for all IBGP neighbors, because in production networks your IBGP neighbors will always be indirectly connected and will be reachable through IGPs only. Have you understood it or not? So this is called fast follower. In case if it comes back up, of course neighborship will come up once again. So I hope that you have understood the feature of follower in BGP. Got it or not? For sure? Great. People have start to sleep. Okay, do one thing. Now after it, let's go for soft reconfiguration. Soft reconfiguration.
सर जब फास्ट फॉलोवर हमने नहीं भी करा हुआ तब भी तो वो चेंज होता ही होगा नोटिस.
अब मैं see, I tried, I mean without enabling fast follower, I shut down the loopback of R1. We saw that R5 didn't break. Yes. But then after I enabled follower, then I went back to R1, I shut down the loopback of R1, then we saw that R5 immediately broke its neighborship with R1. That was the only uses of follower.
सर मेरा मकसद वही है कहने का, क्योंकि वैसे भी उसको पता चल ही रहा है.
नहीं चल रहा ना, प्रॉब्लम तो यही है. कैसे चल रहा है बताओ? उसको बीजीपी को नहीं पता चला ना, वो एसपीएफ जानता है, बीजीपी नहीं जानता. Because the loopback of R1 from R5 is reachable through OSPF only, not via BGP. So if the loopback of R1 is going down, then it will inform to OSPF only, not to BGP. That is why I said that for R5, I mean in terms of BGP, in perspective of BGP, there is no change actually. That is why it has to do wait for next 180 seconds. Not exactly 180 seconds, because might be possible that last keep alive it received before 40 seconds, and then after the loopback of R1 went down, then definitely it will break it after 120 seconds only, or sorry 140 seconds only. So it will be depending on the conditions. I mean maximum it will take 180 seconds, but minimum it will take 120 seconds. Just to reduce that timer, we are using here feature of follower. So let's talk about now soft reconfiguration. Have you understood it or not? So if you talk about the soft reconfiguration feature in BGP, see, thing is like, guys try to understand, like I'm on R1, try BGP, it's receiving all these prefixes from its neighbor. Are you getting my point or not? Hello? Now If I wanna filter, just try to understand now. I wanna filter 100. Do not write anything, right? Just try to understand these things. If I wanna filter 100 and 101, which is coming from R5 as well as R6, I'll require to create. See, I'm covering now route filtering with using prefix list as well as soft reconfiguration. Fine. So to filter all these prefixes, we can create one prefix list over here. IP prefix list, IP prefix list, CCIE deny 192.168.100.0/23 greater than equal to 24 and less than equal to is also. To allow all others, CCIE commit less than equal to. Done. Then after it, go to router BGP. You have two options, either say distribute list, prefix list. Name is in which direction. So now this time this prefix list will be applied for all neighbors automatically because you have configured this distribute list globally. So it will be applied for all neighbors. So from any neighbor, if it receives those prefixes, it will filter them. That's what I want actually. Fine, but your changes will not take place. You have to say clear IPBGP star in, so that you will force your neighbors to retransmit updates. And if your neighbor is retransmitting update, it has to give all updates. Let's say you are having 1 lakh prefixes. Your neighbor has to retransmit 1 lakh prefixes every time. This is going to be very, 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 of course, danger for your network actually. Of course, it's dangerous. That's why we say that BGP must be consistent. BGP table must be consistent. Whatever you want to do, just configure it once and then after forget about changes. Generally, we do not like to make changes frequently in BGP. This is the reason. Because every time whenever you will make any change, you will require to ask to your neighbor to retransmit updates, and then definitely your neighbor's CP utilization and your own CP utilization will be higher. Have you understood it or not? And also your bandwidth consumption will be higher. Got it? Fine, guys. To see that okay, your neighbor has to retransmit updates, what can we do? I will move on R5. I will say debug IPBGP updates. I will move on R6 as well. I will say debug IPBGP updates. And then I'll move on R1. Then I'll say clear IPBGP start in. R5. What is it saying? Sending update? Is not it? Sending update. Are you getting my point or not? And R6 is also sending updates. To whom? R1. Have you got it or not? Fine, guys. If you do not want to let your neighbors to retransmit updates, and if you want to refresh your BGP table by your own, if you do not want to disturb your neighbors during refreshing your own BGP table, are you getting my point or not? For that purpose, in BGP, you can enable soft reconfiguration in this way. Like you move on R1, once again go to your router mode and remove this distribute list from here. Do clear IPBGP star in once again, so that your BGP table will be having all those prefixes now once again, right? Once again, I want to show you here. So see, run this command as well. So IPBGP 150.1.5.1 received. So IPBGP neighbor 150.1.5.1 received. What is it saying? Now everything is fine. When you have received all prefixes from your neighbor, do one thing. After receiving all prefixes, go to your BGP, router mode, and then say neighbor 150.1.5.1 and it can be configured in one direction only, which is inbound. That's it. Just enable it. In same manner, enable it for. But now there is a problem. Generally, in production network, we do not use these commands. We will be relying on neighbors only. The reason is now there will be two tables after enabling this feature. One table will be for received prefixes and one will be your BGP table. So your memory consumption will be just double. One is this, which is your BGP table, and another one will be show IP BGP neighbor received prefixes. See, from this neighbor as well as from this, you see. So one table is for received prefixes and another table will be for BGP. Another will be BGP table. Now the advantage of configuring this software configuration would be here. Like you do one thing, move back again on R5, just press some enter so that previous log messages will be up. Right now, you see, still debugging is enabled on R5 as well as R6. You move on R1 now and configure the distribute list once again. Fine, guys, and again you will see your changes will not take place, but this time say clear IP BGP star soft in. So this time it will not send this request to its neighbor. It will update it from its received prefixes table itself, right? It will not send any route refresh request towards its neighbors. Let me show you. Show IP BGP. So now those I think do one thing, apply it for neighbor 150.1.5.1. say prefix list name was. See, if you are applying it for particular neighbor, then you will not call it under distribute list, you will directly say prefix list. So generally we will be using this feature for route filtering in BGP actually in, and then configure it for 6 as well. And now say and check BGP table now. Is it having 100 and 101? And you move back again on R5. Have it shown you any update over here? Any log message? R6? Nothing. If you move back again on R1, if you are checking its BGP table, you do not have those prefixes. But if you say received prefixes, you are still having all those prefixes. That's why I said that now memory consumption will be just double. This is the uses of soft reconfiguration. So if you have enabled soft reconfiguration for a neighbor, then you will create a separate table for received prefixes, and you will be having all those prefixes in that table. So if you want to allow anything in your distribute list, in your prefix list, or you deny, it will get refreshed or it will be updated via with the help of that received prefixes table only. It will not require to send a route refresh request towards its neighbors. So I hope that you people have understood the uses of soft reconfiguration. It is just to reduce the overhead of neighbors, but you must have enough memory. So generally in production you will not see this feature enabled.
So in case of this last keyword received routes, we use just routes and give us just the filtered routes, right?
Which one?
We use this keyword received routes. Instead of just we use only routes.
Only?
Routes.
Wait. Routes.
It is giving us a filtered routes.
Exactly.
So this, is it taken from the BGP table?
Of course, this is exactly.
This
No, it does not maintain any other table.
it's taken from BGP.
Exactly. Right? Because it is not best in BGP table itself, that is why it is not best over here as well. If you check it, if you check it for 5, see, it will be best. So it is copying it from BGP table itself. Fine guys, so in this way you can use soft reconfiguration. Have you understood it or not? Fine guys, after soft reconfiguration,
ये कमांड ग्लोबली भी है रिक्वेस्ट जैसे पर नेबर हम
what, this soft reconfiguration? No, it's not possible. There is no command, there is no global command in BGP to enable it globally. 65500 see BGP soft reconfiguration, nothing. Soft reconfig backup is there. I don't know what is the uses of this command, just wait. Okay, you can oh, it's possible. I mean, you can also configure this command soft reconfig backup. It will also work same as that you configured per neighbor, right?
What is global mode of the
This is in global mode, router mode. You are not applying it for particular neighbor. This time it will be applied for all neighbors. Fine guys, so this is all about the soft reconfiguration. Then after it, you can also use one keyword like remove private AS. Allow AS in, I hope that you people understand what is the uses of allow AS in. Like if you are receiving prefixes with your own AS, you will discard them. But if you want to allow them, you have to say for that neighbor you can say allow AS in. With using command, like if you are on New York router is receiving some prefixes with same AS which are coming from BT. So we can also configure this command as well, like 8000 neighbor 80.1.1 allow AS in. That's it. After running this command, it will also start to allow those prefixes which are containing our own ASs. So that is the meaning by allow AS in keyword. Apart from it, we can also use one remove private AS keyword as well. Remove private AS. Let's say that I'm an ISP actually. Let's say I'm an ISP and I am connected with my customer. Customer is advertising prefixes with using private AS. Then ISP1 is giving those prefixes towards ISP2. Now remember that when one ISP will advertise those prefixes towards another ISP, you will never advertise those prefixes with private ASs. So let's say this time we do not have any connection in between R5 and Sprint US. So move on R5. Router BGP 65500 do show IP BGP summary neighbor. Just shut it down. So and move back again on BT. And here I shut down that neighbor. Just no shut it. 35500 neighbor 101.1.1. Shut down. Say no. So it will come up. Neighborship will come up now. So fine. So now Sprint US will start to receive these prefixes coming from BT, which is another ISP, right? So BT is receiving prefixes coming from customer with private AS and advertising them towards Sprint, which is another ISP. So if you move on Sprint US now, you will see that it will start to receive these prefixes coming from, you understand, with the private AS. Now you have to configure this BT so that whenever it will advertise any prefix information towards Sprint US, it must remove private AS information from them. So for that purpose, you just need to configure only one command on BT itself. Like router BGP, it's using 35500. So neighbor, it's 101.1.1. Remove private AS. Remember, this command can be configured only for eBGP neighbor. And only for that eBGP neighbor which is using public AS, not for that eBGP neighbor which is using private AS. So this time you see that Sprint US is using public AS, which is 21545. So this time after running this command, whenever this BT will advertise any prefix information towards Sprint, you will see that Sprint will not get any private AS information. You see, say clear IP BGP star in. And once again check its BGP table. My god. Say clear IP BGP star. Just wait for a moment. Let it form neighborship. Once again, let it receive all prefixes coming from that neighbor. Just wait. See, they are containing only 35500, not 65500. However, they are actually originated from AS 65500. Just wait, let it define best. See, have you understood the uses of remove private AS keyword? Fine, guys. Now we are also having, like, here let me tell you something related to route filtering as well. On R1 show IP BGP, it is not receiving all those prefixes. Let me remove this prefix list from here once again. And you can also configure this prefix list in outbound direction as well, right? So IP BGP, once again you will start to receive it, right? Let me show you that how can you configure distribute list in BGP to perform route filtering. Router BGP 65500. See, distribute list, as I said, that if you are configuring distribute list globally, it means it will be applied for all neighbors. And here in this distribute list, you can call either standard ACL, extended ACL, or prefix list, or you can also use gateway keyword, right? Fine, guys. This is that you can apply it. I mean, you cannot call route map over here, right? Then you can also configure distribute list per neighbor as well, like neighbor 150.1.5.1 distribute list. But here per neighbor under distribute list, you can configure either standard ACL or extended ACL only. You cannot call prefix list. If you want to configure prefix list, then you have separate keyword which is prefix list itself in both directions, like CCIE out or in. Then after you do not have anything. So generally this method is used in BGP to perform your route filtering. Like prefix list will be configured per neighbor in both directions. You can configure it for inbound updates. You can also configure it for outbound updates as well. Have you understood it or not? So in this way, you can configure prefix list as well as a distribute list. So is it required for me to perform practicals for you here of this distribute list for route filtering? The uses of extended ACL is quite different in BGP. Only that practical I will show you, right? I will perform that practical of that extended ACL only, right? Here in BGP, uses of extended ACL is quite different. It is same as prefix list actually. The uses of extended ACL and the prefix list in BGP is same for route filtering. Like in prefix list, we can say greater than 23, less than 25, 26, something like that. I mean, we can also filter prefixes which are coming on different prefix length. Same task we can also achieve in BGP with using extended ACL as well. With using extended ACL, and let me perform that. I'll move on NEOC router. I'll create some loopbacks 101 IP address 90.1.1. Sorry, let me do it as 192. Loopback 102. This is 1.66 or 65 would be enough. Loopback 103, and this time 1.129, and in place of 192 I will make it 120. Loopback 104, 90.1.2.1, and last we can make it 252. Loopback 105, 2.5, loopback 106, 2.9, and in last I can make it 248. Loopback 107, in place of it now I'll make it 17, and in place of it I'll take 240. 108. Here I'll take now 33. Here I'll make it 224. Loopback 109. In place of 33 I'll make it 65, and here I'll make it 192. Loopback 110, 120, and here I can say 129, and in last I can say 120. That's enough. You will see on R1 all these prefixes will be present. So IP BGP. Let me show you. Fine, guys. Some prefixes are coming on /26, 25, 27, 28 as well, 29, and /30 as well. Let me, yes, see. It's not 8. So now if you want to perform filtering here for 90s prefixes which are coming only on slash, tell me 26 and 27. You want to filter only those prefixes which are coming on slash 26 and 27. So see, of course, the aggregate address for all of them will be, tell me, 90.1.0.0, and then wildcard mask will be 0.0.3.245. In it, all of them will come, but we want to filter only those prefixes which are coming with subnet mask slash 26 and slash 27. See, all of them are coming within this range, fine, but we have to filter only those prefixes which are coming on slash 26 and 27. So if you are taking subnet mask as 245.192, which means 26. 245.245.224. You just need to filter only these prefixes. So what will be wildcard mask for these subnet mask actually? Like you do one thing, of course first 3 octets must match, so your wildcard mask will be 0.0.0 for first 3 octets, and in last octet there are changes, and I'll let you know that what will be your wildcard. And the aggregate subnet mask would also be aggregate and accordingly you have to create its wildcard mask. See, if you convert last octet into the binary, because we have came to know that what will be wildcard mask for first 3 octets, right? Because it must match. You do one thing, convert 192 into binary, so it will come 1 1 0 0. Fine. 1 1 1 and all others will be 0. So we just need to match slash 26 and slash 27. We know very well that only these 2 bits must not match. Only these 2 bits must not match, and apart from it all others must match, or only these 2 bits must match. What will be? Say I want to match only 192 and 224. That's it. It means only these 2 bits must match. Sorry, must not match, and all others must match. Only these 2 bits must not match and all others must match, because it can be anything. Apart from it, all bits must remain same, so that only these 2 values will come out, 192 or 224. See, this bit must match. 1 throughout, right? 0 throughout must match. 0 throughout must match. 0 0. So it means, see, now in subnet mask you can take either this value or this value, but wildcard mask must be like, because as I said, first bit must match, so 0, then second and third bit must not match, so 1 1, then 0 0 0 0 0. So what will be your wildcard mask value now? 64 plus 32, it will become 96. So this, it should be your wildcard mask. And now see, if you type 255.255.255.192 space this wildcard mask will work. The meaning will remain same. If you take 255.255.254 and this wildcard mask, again meaning will remain same. This time you are matching your subnet mask not to IP addresses. Just try to understand. You are matching only slash 26 and 27. Are you getting my point or not? You are matching slash 26 and 27 only. So you converted it into the binary. You see that even I will say even I will not require to have 96. See, this 1 1 is also matching, right?
Yeah.
We can also say that okay, it must match. So here also we can take 0.
Yeah.
The only this third bit is not matching. So in place of third bit I can take 1, so it will be 32 now. However, it will also work. See, 96 will also work. But the problem is that we want it to take only /26 and /27. So we can achieve it by using this bit only. So in /26 these things will match. In /27 also these things will match, right? So now see, I will move on R1. I'll say access list 101 permit IP source. In source you have to call your prefix. So it was 90.1.0.0, then 0.0.3.245. So that all of them will come into it. Now in source you have to see this is completely different from OSPF, RAID and EICRP, because in source we were taking over their source address from where you are receiving prefixes, but here in source you have to specify your prefixes to whom you wanna permit or deny. So here I wanted to deny them actually, right? So in place of permit say deny, and then in destination you have to specify your subnet mask information. So now say 255.255.192 and then wildcard mask for your subnet mask. So it will be 0.0.0.32. And then access list 101 permit IP any, then router BGP 65500 neighbor 150.1.5.1 distribute list 101 in which direction, in, as well as you can apply it for 6. So clear IP BGP star soft in show IP BGP. Wow. From that range only prefixes are coming here, but only on /25, 27.
27
Okay, because we filtered 26 and 27 both of them. So 25 is there, so let's try 28 is there, 29 is there, as well as 30 is there. I hope that you people are now hanged. Your brain is hanged now, completely hanged, because it's quite different, and that is why due to these difficulties they developed prefix list due to BGP. Because of course it was having too much difficulties, because it's not very easy to calculate the wildcard mask for subnet mask. So generally we were saying that wildcard mask, this subnet wildcard mask is reverse, or it's reversible to the subnet mask. So do not correlate subnet mask with wildcard mask. Even see here we calculated wildcard mask for subnet mask itself.
Yeah.
You understand? So that's the only thing. Fine guys. So now it will be good, I think, for me to cover all other topics in next class of BGP.